Hi everybody, how are you? Thank you for taking the attendance down to the class secretary. Today we are starting our first lesson that we're going to do in our Module 2 notebooks, or workbooks. So you should have gotten one of those yesterday, Monday, after we finished the test. So if you were absent yesterday, I have set aside your module, so please get that from the substitute at this time. But we are going to work actually on lesson 9 to start off with, because you know from the last module we like to kind of skip around and pick and choose and prioritize. So we're going to go to module 2, lesson 9. All right, so the goal of this lesson is that you will be able to convert fractions to decimals, which you already should know how to do from module 1, and then take it a step further and then add and subtract decimals. All right, so that's our goal. First thing we're going to do is review some things that you already learned in module 1. First of all, decimal place setup. So we talked about place value, and we're going to talk about how that kind of correlates to how we write fractions. Okay, so we talked about tenths, hundredths, thousands. We'll go over that in a minute. The other thing we're going to review is magical denominators. So we talked about this when we were dealing with percents, and if we want a percent, we want to take one fraction and see what it is as a percent. Maybe we could scale it up to 100, for example. That came really easily if it was a magical denominator. And then we're going to look at the old standby way of converting any fraction to a decimal. So the first thing we are going to look at is place value for decimals. So I copied this chart from the internet. So it's the decimal place value chart. So you can see the decimal point here in the middle in kind of a pink color on here. And then to the left, those are all whole numbers. You're really good at dealing with whole numbers already, because those are the numbers you dealt with since you were a little kid. But now we're kind of venturing down this avenue down here, okay? So we are going to take a look at why we use tenths, hundredths, thousands, 10,000s, 100,000s, and 1 million. So if you were to write, tenths, that's a number out of 10, right? And a hundredth is out of 100. And a thousandth is out of 1,000. And we could keep going on and on to infinity with this, right? And you'll notice they're all ones with zeros after it. When we have a 1 with zeros after it, and you'll learn about this more later in your schooling, but this is what we call a power of 10, right? It means essentially 10 multiplied by itself. So, we have tenths, but then we have hundredths, which is 10 times 10, thousands. We keep tacking another zero on the end. So our decimal system is based off of the whole concept of 10. So when we have a decimal that, for example, 5/10, I'm going to write this up here, for example, you would read this fraction 5/10, but the decimal would be 0 ones, the decimal point, you read that and then 5/10, right? Let's say, I'm going to do this next one in red, let's say we have 32 hundredths. Right? So 32 hundredths would be 0 ones, and you want that last digit, in this case a 2, in the hundredth spot. So it would be written like that. So 32 hundredths. Thousandths, same kind of thing. So let's say we have 67 thousandths. Right? So we'd have 0 ones, and then we want 67 thousandths. So you want the last digit in the thousandth spot. So it would look like this. Okay, so again, you read it based off of where the last digit is. All right, so when we read a decimal, it's really easy to convert that into a fraction. We would just take how we would read that and put it over, that power of 10. So, 5/10, that would be 5 out of 10. 32 hundredths, it would be 32 out of 100. And 67 thousandths would be 67 out of 1,000. And then, we can simplify these things if you can simplify it, but, like 5/10 would be the same as 1/2, for example. And we could obviously scale down 32 hundredths, etc. But what happens is a lot of kids see like this example, and we talked about this when you did your test, like they'll see 5/10 and they see the number just slapped down. And that works when you have a power of 10 as a denominator. So you'll notice all of the denominators are powers of 10. That's why we can do that. But we're going to talk about situations where that doesn't work in a minute. So anyway, just a quick review of decimal place value. All right, so you'll notice there is a decimal point in all of these. Now whole numbers do have a decimal point even though you don't always write it or see it. So if we had the number 45, for example, you would not write 45 and then a decimal point. You would just write 45, right? So it's kind of like it stays in the background. We don't need to bust that out unless we're dealing with the right side of this chart, all right? So it's something that's there. It just doesn't always get written or show up unless we have to, which is when we have numbers to the right. Let's look at the magical denominators. Now we talked about these when you're scaling up to something out of 100. So you could also do this out of 10, but if you can scale any fraction up to a power of 10, then that makes it really easy to convert it over to a decimal. So for example, 3/4, written like this, we could scale that up. We can't scale it up to 10, but it does go into 100, right? So we know 4 times 25 gives us 100. So if we did the same process to our numerator, we would get 75 hundredths. And that's how you would read this fraction right here, 75 hundredths. And we would read this decimal the same way, 0 and 75 hundredths. Right? So when we have one of these fractions, like 1/2, we could scale that up out of 10. Right? 2 times 5 gives us 10, and 1 times 5 gives us 5, so we have 5/10, so we would write that as 0 and 5/10. All right? And then this should be reviewed, so I'm not going to spend a ton of time on this, but let me extend the page a little bit. 8 out of 20. Well, we could actually scale this down. We could make it 4 out of 10, right? Right, so we would write 4/10 like this, right? 0 and 4/10. We could also take 8/20, and we could scale it up to 100, another power of 10, right? And 20 times 5 is 100, and 8 times 5 is 40. So 40 out of 100 is 0 and 40 hundredths. But this last 0 on the end, you can chop that off, okay? That's optional. So these are mathematically equivalent. Let's look at the last one here. If we had 9/25, to find out what that is as a decimal, well, we can make it out of 100 by multiplying it by 4. 9 times 4 gives us 36 out of 100, so you would read that 36 hundredths, and this is how you would write the decimal equivalent of that. So that's all fine and good when you have numbers on the bottom, the denominators right here, that scale up to a power of 10. But what do we do if we have something that doesn't? For example, if we have a denominator of 3, that's not going to scale up to a power of 10. Or what if we have a denominator of 9? That's not going to work for us as well. So we need to take a look at a different method that we talked about extensively. What else can we do to change any fraction? It will work with absolutely any fraction. And we want to turn that into a decimal. Well, it's pretty easy. You're going to divide the numerator, which is the top number, by the denominator. So if you have your calculators right now, let's do an example. Let me see if I can get the calculator on the screen. Please hold. Okay, well, Google has a calculator, so here we are. Let's see if I can write on this. I don't know if I can. I've tried this before. And, oh, I did. Okay, so if I have the fraction 5/9 and I want to turn this into a decimal, you know, you could try, oh, I'm going to scale it up, make it out of 100. Well, you know what? You can't do that because 9 is not a factor of 100. So what we can do is you take your top number here, this 5, and we're going to divide that by this 9, okay? So one thing you may have noticed is I don't know if this is intentional. I should look into it. But this symbol for division, doesn't that look like a fraction? So we are going to take our top number, divide it by our bottom number. So we have 5 divided by 9. Now you're going to get a fun repeating decimal here. So you're going to get 0.5 repeating. On your calculators that you have in front of you right now, if you divided 5 divided by 9, again typing in the top number first, you're going to notice that the last digit that they put on the screen is a 6, because realistically, you know, at some point you're going to have to round that, because that would go on and on and on forever, kind of like my YouTube videos. Just kidding. So anyway, you're going to take, you know, you're going to have to round it at some point. So you're going to get 0.5. Let's round to the nearest thousand. So this is a 5, but we got to look at the 10,000ths place. Whoops, it's another 5. So you're going to, you know, look back here. If that number is strong enough to bump up the number in front of it, we're going to change that to a 6. All right? Or if you wanted to round to the nearest, this is not writing very well right now. Where'd you go? What in the world? All right, if you want to round to the nearest 100th, you would, you know, why did I write 0? Let me erase that. I'm going to erase this too. I need some room to work. There we go. So again, if you take 5/9, take 5 divided by 9, you're going to get 0.5 repeating, and that's when you can use a repeating bar up on top of that 5. That means anything you have that bar over, that means it's continually saying those numbers. So if we have this, that would be approximately 0 and 56/100ths. You could round it because it keeps going, right? We could say that is 556 thousandths. Like, we could keep going with that. Anyway, you get the point. Divide the top number by the bottom number. So on your calculator, let's do a few examples. So let's do 5/6. So 5/6 equals. So in your calculator, you're going to type in 5 first, and then over 6. So divide by 6. So I'm going to clear this out. Excuse me. Let's see. How do I get rid of that old? Huh. Google's fancy. All right, 5/6. So 5 divided by 6. So let's type that in. 5 divided by 6. You should have gotten 0. Why is that doing that? 0.83, and the 3 is repeating, so I can put a bar over that, but that would keep going forever. All right. Let's try another one. Let's do one we know will come out to something that we know to be true. 1/2, so take 1 divided by 2, you are going to get 5/10ths, right? So 1 divided by, let me erase, 1, delete that, 1 divided by 2, ugh, clear it out, 1 divided by 2 equals 0 and 5/10ths. So a lot of kids on this one worksheet, and I'm thinking I'm just going to throw it out because so many kids made this mistake. They actually would do this: 1/2 equals 0.12, or they'd say this: 1/2 equals 1.2, and I'd go, ah! All right, don't do that, guys. Use that fraction bar to divide. All right, so the next thing we're going to do is do our module lesson. So this shouldn't take us very long. We're going to use whatever's left of the class for you to work on your homework. So let's get this going. And all right, we practiced a bunch. Let's go to the next page here to add and subtract decimals. So we did a fairly lengthy review on how to change fractions into decimals. So scale it up to a power of 10 was method 1. Method 2 will always work, and that's divide your numerator by your denominator. Take the top number, divide it by the bottom number, and that will definitely work to change any fraction into a decimal. All right, so again, I kind of gave that away. To add and subtract decimals, we've got to line up the decimal point, right? That's what today's lesson is, add and subtracting decimals. Line up the decimal points and do the operation.
That was easy.
Yes, it was. All right, so let's now flip to our modules. This is the beautiful cover of Module 2. So beautiful. All right, when you're done admiring that, please go to the first lesson, which is a few pages in, because you have some of that reference material in the front of your module. We'll tab that off when we have a minute if we haven't already, but don't stress, kids. All right, so you guys are really going to love Module 2. Your parents are going to love Module 2 because this is old school math, right? This is the kind of stuff that everybody everywhere needs to know all the time. Basic stuff, all right? This stuff hasn't changed in a long time. So we have 25 and 3/10. Now, this first example here, which we should write the date down. So the date then, I'm recording this on the 25th, so Saturday's the 26th, 27th is Sunday, Monday's the 28th, so 10/29, so 10/29/19 is the date, all right, and we are finding the sums and differences of decimals. So the first thing we need to talk about is the word sum. When we are asked to find the sum, that's a fancy way of telling us to do addition. And when we see the word differences, that's a fancy way to tell us to do subtraction. So we just need to make sure we know that. Anyway, 25 and 3/10. So we could write this as 25 and 3/10 plus 376 and 77/100. Right? They already wrote that down. I don't know why I did that again. So I'm going to change this fraction to a decimal. So 376.77. All right? Now, we don't add across like that unless we're just using a calculator. Well, you know what? We're going to probably not use a calculator very much this module because this module is based on you knowing and understanding how to do these calculations. All right? So the goal of this module is to get you better at doing this yourself. So 25 and 3/10, we're going to stack this. Now, the biggest mistake kids do, and everyone put your pencil down right this second, do not write this down. They do this. They will just, okay, so 7.67. They write it down like that, and then they add. And then they get some ridiculous thing. All right? Do not do that. That is garbage. What you need to do is line up the decimal points. So 25 and 3/10 plus 376 and 77/100. So the 77/100s go back here. We've got 6, we've got a 7, we've got our 3, lining up all of the place values. Now do not draw this on your paper necessarily, but notice that everything is in their little place value boxes, okay? So I'm going to flip back to a different page. So just like we did here, right, you want to stack it the same way. So that decimal point needs to be lined up. That is the only thing you really need to know to add and subtract decimals, all right? It is super easy to do. Now you'll also notice that above this last 7 here, there's nothing, right? So we can fill that in with a 0, all right? So 0 plus 7 is 7, 3 plus 7 is 10. We're going to bring down that decimal point, carry our 1. We're going to have 5 plus 1 is 6, 6 plus another 6 is 12, carry your 1, and 1 plus 2 is 3, 3 plus 7 is 10, put your 0, carry your 1, 1 plus 3 is 4. So really, this is not complicated. It just requires some attention to detail and being careful with lining up the decimal points. All right, so that was example 1. Example 2 is the same kind of thing. We're converting any fractions to decimals. So 1/5, we've got to convert that. Now that is not one that easily, we can't just say 0.15 because that's not accurate, right? We need to take 1 and divide it by 5, or we need to say, okay, 1/5 equals what out of 10, right? And we want to get this to a power of 10. So 5 times 2 is 10, 1 times 2 is 2. So that is the same as saying 2/10. Now if you don't believe me, you can take your calculator right now and put 1 divided by 5, typing in the 1 first, divided by 5, you're going to get 0 and 2/10 that way as well. So this number would be 426 and 2/10, right, minus 275. And 1/2 is when you really should just commit to your memory. 1 divided by 2 is going to give you, or 1/2 of something is 0.5, right? So there you go. But again, I can show you 1/2, we can make that a 10, right? 2 times 5 is 10, 1 times 5 is 5. So 5/10 would be read like this, or look like this, and read the same as the decimal. All right, so anyway, let's stack these up. So 426 decimal point 2 minus 275 decimal point 5. You don't need to throw any zeros in because it all ends in the 10th place. So we are subtracting. So you cannot take 5 from 2. You've got to go next door, borrow. So we have 12 minus 5. 12 minus 5 is 7. We'll bring down our decimal point. We changed our 6 to a 5. So now we have 5 minus 5, which is 0. 2 minus 7 isn't going to work. We've got to go to our buddy 4. 4 is going to become a 3, and now we're going to be 12. 12 minus 7 is 5. And 3 minus 2 is 1. Now you guys probably already know this, but if you want to check your work, you add these two numbers to see if it gives us that top number. All right? So there you have it. All right, so the rest of these exercises are really just simple. It's you converting fractions to decimals and then adding or subtracting. All right, so calculate each sum or difference. Samantha and her friends are going on a road trip that is 245 and I think that says 7/50 miles long. They have already driven 128 and 53 hundredths. How much further do they have to drive? So we need to turn these into decimals. Right, so we have 245 and then a partial number, right? 7/50. Well, if we scale 7/50, I'm going to do it up here, 7/50 up to 100, right? We multiply it by 2, multiply this by 2, we're going to get 14 hundredths, right? So that's 0.14. That's how you do that. Now, if you're more of a calculator-like person, but you don't have one, that's the kind of the thing with this. We're not going to be using calculators a lot, but just to show you what's what, we're going to take, let me clear this out, 7 divided by 50. If I did it right, I should get 0.14, and I did. So there you go. And then we're going to take 128 and 53 hundredths. That one's really easy because it's already in that power of 10. So 128 decimal point lining up. They're directly over top of each other. And then 53 hundredths, we can just write that down because it was a power of 10. So again, we need to figure out how much further they have to drive. So that's going to signal us to subtract. So 4 minus 3 is 1. 1 minus 5 can't happen. We've got to go next door, make that 4. Turn that into 11. 11 minus 5 is 6. 4 minus 8 can't happen. Change this to a 3. 14 minus 8 is 6. 3 minus 2 is 1. And 2 minus 1 is 1. All right, so our answer is they have 116 and 61 hundredths miles left to drive. All right, any questions? Hopefully not, but if you have any, the substitute can probably help you with that. So let's go to the next page. Ben needs to replace two sides of his fence. One side is 367 and 9/100 meters long. The other is 329 and 3/10 meters long. How much fence does Ben need to buy? So we've got to figure out how much total fence he needs. We have one side and the other side. So let's add those up to see what he needs to buy at his favorite home improvement store. So 367 and 9/100. Now a lot of kids are going to make the mistake and slap down 0.9, right? But this is 9/100. So we've got to have 0 in the tens place, and then 9 goes in the hundredths spot. We have 329 as our second value, and 3/10. So 3/10 would look like that, right? And we want to add those. Now you'll notice there's not a 0 below the sign. Well, we can add one because that does not change the value of our number at all. So 9 plus 0 is 9, 3 plus 0 is 3. Bring down that decimal point. 7 plus 9 is 16. Carry the 1. You're going to get 1 plus 6, which is 7. 7 plus 2 is 9. And then 3 plus 3 is 6. So this is going to be an expensive trip to Lowe's. 696 and 39 hundredths, and we're talking about meters of fence. All right, so again, you just have to use these skills that we've learned. We'll do a few more, and then I'll let you get started on your homework. All right, now the idea again is that you do this on your own. So when you have your homework, I want you to make sure you are showing your work just like you are right now, and you are not using a calculator to do the calculations. The only thing that I would like you, if you choose to use a calculator for, is to check your work. But the reality is you're not going to always have a calculator, especially when it comes to 6th grade. So, you know, this is a basic skill you need to know how to do. So we're going to step away from those a little bit. All right, so Mike wants to paint a new office with 2 different colors. He needs 4 4/5 gallons of red paint and 3 1/10 gallons of brown paint. How much paint does he need in total? So he needs red paint, he needs that much brown paint, and it says how much does he need in total. So 4 5/5. That's going to equal 4 and 5. The 4/5 part, if you take 4/5, right, and you scale it up to tenths, that's going to be 8/10, right? So 8/10 you'd write like this, right? And then we're going to have 3 and a tenth. That would be the same as saying 3.1, right? So now we're going to take these two numbers and we're going to add them. So 4.8 and 3.1. Adding those up, lining up, again, the decimal points, we're going to get 9/10 there. Bring down your decimal point, and 4 plus 3 is 7. So 7 and 9/10 gallons is our answer. All right, a few more. Just for time's sake, we're going to cut it off a little early here. But after Ariana completed some work, she figured she still had 78, and let me erase this, 21 hundredths pictures to paint. Well, that's pretty specific. If she completed another 34 and 25 pictures, how many pictures does Ariana still have to paint? That seems ridiculous. Okay, great example, module, great example. All right, so anyway, 78 and 21 hundredths is already in the form we need it to be, to just write it down like this, because we would read the decimal 78 and 21 hundredths, and we would read that fraction written in the word problem as 21 hundredths. So that's mathematically equivalent. It says if she completed another 34 and 23/25 pictures, how many pictures does she still have to paint? So we want to find the difference between these two, so we're going to subtract, but I need to know this number. So 23 out of 25. We can scale it up. Now again, you can take your calculator and take 23 and divide it by 25. So let me do that. 23, let me clear that. Let me change it to an eraser and erase that. All right, let's do that again. Okay, so what were the numbers? I forgot. Hold on. 23 divided by 25. There we go. All right, 23 divided by 25 equals 92 hundredths. So, in case you don't believe me, 92 hundredths we said. Okay, so that was through the division method. 23 out of 25 equals 92 hundredths, like that. Now you could also look at this. All right, I want to scale 25 up to a power of 10. So the easiest one we can do is to 100. So that's times 4, and 23 times 4. So I'm going to do this over here. 23 times 4. You're going to get 3 times 4, which is 12. 4 times 2 is 8, plus 1 is 9. So you're going to get 92 that way. All right, so anyway, we have 34 and 92 here. That's how many she has already done. So we need to subtract. So 1 minus 2 doesn't work, so we've got to go next door. Make this a 1. We're going to borrow. That now becomes an 11. And we are going to have 11 minus 2. 11 minus 2 is 9. 1 minus 9 can't happen. We've got to go next door and make that a 7. So this is 11 minus 9, which is 2. Bring down your decimal point. 7 minus 4 is 3. And 7 minus 3 is 4. So this girl has 43 and 29 hundredths of a picture, or pictures, all right, pics left to paint. She better get busy with that. All right, pretty easy stuff. This next page I'm probably going to skip. You know what? No. Let's make this your homework. I was going to give you a separate sheet for homework, but I think this will be good, because then you can use various methods. If you want to scale it up out of power of 10, you can do that and then convert it to a decimal. Or you can take the calculator and take, like 3 divided by 4. That should give you a decimal. But if I see any papers, and do not do this, everyone pay attention, if I see anybody do this, 3/4 equals 0.34, I am going to go insane, all right? That is not the case. So make sure you are not doing that. You're scaling it up to a power of 10. See if you make it a tenth, make it a hundredth, make it a thousandth. All right, if you can't, remember that division bar, right, that fraction bar means division, and you're going to divide your top number by your bottom number. Now, number 6 says use a calculator to find each sum or difference and round your answer to the nearest hundredth. So we've talked about this. If you need to round, so be it. All right, so you can have the rest of class, if there's anything left, to do page 3 for homework. Actually, in your book, it's not page 3. In your book, it is page 4. So page 4 is the homework for this evening. So I'm just going to scribble this out. 4. There you go. All right, I hope you guys have a great rest of your day. Thank you for being so helpful. And if anything else comes up, please make sure that you lend a helping hand. Thank you to the substitute for playing this video, and have a great day. Thanks. Bye.